So what we worked on today in class was this molecule, see here, food coloring red 3, and the assignment was to fill in all of the missing atoms here that are not shown, as well as the valence electrons. One reminder before we get into this, you should remember that hydrogen loves to take only one bond. Again, that would be 2 valence electrons to be shared. Oxygen likes to take 2 bonds, as you can see, for example, here. But then when you write it out, don't forget to put the 2 pairs of unshared electrons that will go on the outside of oxygen. Then nitrogen, which we don't have any nitrogens at all on this molecule, but nitrogen likes to make 3 bonds and usually has 1 unshared pair. Carbon likes to make 4 bonds. Iodine, like you see here, likes to make 1 bond and have 3 pairs of unshared electrons. Carbon likes no unshared pairs. So here we have this molecule. Now what I'd like to do is figure out the formula for this molecule. I mean, how many sodiums, how many carbons, how many hydrogens, how many oxygens, and let's see, how many iodines. I think that's all the elements that are on here. So we're going to try to figure out what the formula is for this, the final formula. All right, so let's go ahead and take a look at this. Now this element right here is iodine. I'm making it into a capital I. Just remember that every time you have a halogen, which is group 7A, you need to put in the 3 pairs of electrons on the outside. This is a single bond, which is what iodine likes. Now right here it sets a carbon. Carbon fits in all of these funny places where it looks like something's funny going on. That's where your carbon goes. Like there, like there, like there, like there, here, and here. Carbons are going in all those places. A carbon likes to take 4 bonds. So this one has 4, 1, 2, 3, 4, 4, 4. This one only has 3, which means that if you have a carbon with only 3, it needs to have a hydrogen there. That hydrogen is missing, but we need to include it in the formula. All right, here we have 4 bonds for the carbon and 4, so this is good. Over here we have 2 unshared pairs on that oxygen. And over here, this again is another I as in iodine. And I'm going to put the unshared pairs here for iodine, 3 pairs. Moving this way, this oxygen has 2 unshared pairs. There's a carbon here, carbon here. This iodine has 3 unshared pairs. There's a carbon there. Now as we move up this direction, this oxygen is attracted to this sodium here. This oxygen has only a single bond, meaning it has 3 pairs of electrons that are unshared. This is a negative charge on this. I want to know that this sodium here, this atom of sodium, is a positive charge. So these are attracted to each other. That's an ionic bond. Okay, as we move around the molecule, here we have this iodine with its 3 pairs. We have carbon. Now this carbon needs a hydrogen. It only has 3 bonds. And that carbon doesn't need a hydrogen, nor does this one, 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 or this one. Okay, so now this oxygen needs 2 pairs. This oxygen, like the other one up here, same thing, needs 3 pairs. And again, this is an ionic bond here. It's not covalent. That's negative. We have 2 ionic bonds here. Moving around, we're going to need to add a few hydrogens here. They are not shown, but they do exist in this formula. So that now they need to be added in. And as I work around the corner, that's looking pretty good. I don't see any problems. I think I'm finished. So now you'll notice we have 2 sodiums, 1, 2. Carbons, if you count all around the circle, you should count up to 20 carbons. Hydrogens, I counted 6. Oxygens, 1, 2, 3, 4, 5. and iodines I count 4. So the way this is shown, this is actually an ionic compound. This whole thing is an anion with a -2 charge, sodium +1 charge. And so on a test, you're going to need to go in and fill in all the little dots and dashes and complete these types of molecules. Thank you very much.